Okay, in the next step, we want to construct a table, the iteration number, ti value and xi value. I start from 0, 1. Okay, and t begin with 0 value by using the step size of 0.25. We need to iterate until it reach 1, and we stop because that is the boundary value. Okay, so we have 4 iteration, and for the x value, the first value is given, right, which is x0 equal to 0, and the last value is also given, x1 equal to 1. So you have to find the remaining values. Again, note that this is x0 and this is x4. So you have to find x1, x2, and x3. What are they? Okay. So from here you can create 3 algebraic equation where we start by using I equal to 1. Substitute into this equation, okay, this equation. If I equal to 1, you will get this value. Okay, we replace I value by 1. Okay, this is sign here. So what we can substitute here is value as 0 is 0. Okay, you can refer to the table, x0 is 0, right? And then what else we can substitute is the value of t1. What is t1? t1 is 0.25 here, okay? I is 1, so 0.25. Okay, make sure you are using radian because we have trigonometric here. Yeah, in your calculator you have to set to radian mode. And then what we have is here. Then we go to the next iteration when I equal to 2. Okay, so for this stage we can insert t2. T2 is 0.5. Okay, and you obtain this. Equal 0.2577. Next, go to the third iteration. Okay, so now you know what is your x4. It's obtained from the table. X4 is 1. And also for T3 is 0.7. Then you calculate, you will get this value. Okay, now you have 3 equations. We are referring to this 1, 2, 3. Okay, 3 algebra equation where we need to convert into tridiagonal matrix. Okay, so the system involves 3 vectors, y1, y2 and y3. So for this case, remember we are not using y, okay, we are using x, so you have to know how to adapt x1, x2, x3 as the vector. And the answer is what's on the right. And the matrix itself should be written like this. Okay, you just take from the equation here. The first row is obtained from the first equation, and the second one should be obtained as stated here. And the last row is here. So this is tridiagonal matrix. Okay, where the diagonal is this one, and it is accompanied by the lower part and the upper part of the diagonal. So we can apply Thomas algorithm to find the answer. Okay, since this is tridiagonal, you can use Thomas algorithm. And remember that for Thomas algorithm, you have to know the labeling. Okay, for the matrix, the answer is B, and the diagonal is labeled by D. And for the lower part is C, and it started from C2, and the upper part is E. Okay. So in applying Thomas algorithm, you have to construct a large table consists of the value of y. Okay, here we are referring to x. So you can develop like this. So we will have 3 columns because the size of the matrix is 3 by 3. So we divide the table into 2 parts. The first part is the data from the matrix. Okay. So for the first row, we want to put B values. So here is your B. You just need to list it down. List that as the first value. Next value is this, and the third value. Then the second line is C. C is starting from C2. Okay, so no value for C1. And then we start from C2. Okay, next is D value, is on the diagonal part. You just need to copy everything. Okay. Lastly, on the first part here, we want to write E. E is here, start from E1, E2, and no value for E3.